Welcome, everyone, to today's in depth webinar titled Understanding SPRD, a Step Beyond Conventional Radiation Detection. I'm Alan, and it's a pleasure to have you join us today as we explore the significant advancements in radiation detection technology, specifically focusing in on spectroscopic personal radiation detectors, commonly known as SPRDs. Radiation detection has been a long, for a long time, been a cornerstone of safety and security across a wide array of industries. So whether you're talking about healthcare or nuclear power, environmental monitoring, or national security, the ability to detect and identify radiation quickly and accurately is absolutely critical. So, over the years, we've seen various types of radiation detection tools, each with its own set of strengths and limitations. However, the introduction of SPRDs marks a transformative step forward in how we approach radiation detection and identification. So, Berkeley Nucleonics has been at the forefront of this transformation for decades, with an experience in cutting edge solutions for radiation detection. We've been instrumental in pushing the boundaries of what's possible with radiation detection technology. Our commitment to innovation is driven by the needs of our customers and the evolving challenges they face in their work environment. So, what can you expect from today's session? Our goal is to provide you with a comprehensive understanding of SPRDs, how they differ from conventional radiation detection devices like your regular pagers and handheld isotope identifiers, and why they're becomingly increasing requests in a variety of applications. So, through this webinar, we'll break down the key components and functionalities of SPRDs, discuss their practical applications, and provide insights into how they can be integrated into your existing safety protocols. So by the end of our time together, you will have a clear understanding of not only what SPRDs are, but also what they represent and a significant advancement over traditional detection tools. So let's embark on this exploration together. And like I said, by the conclusion of this session, I hope you'll share enthusiasm for SPRD technology and the potential it holds for enhancing radiation detection and safety practices. Okay, now that we've set the stage, let's go a bit deeper into the specifics of SPRDs, what they are, how they function, and why they're considered a next generation option in the field of personal radiation detection. So, an SPRD, or spectroscopic personal radiation detector, is more than just a simple radiation detector. While traditional devices like the radiation pagers, many of you are familiar with, are designed to alert the user to the presence of radiation. SPRDs take this a step further by offering spectroscopic analysis. So that means that SPRDs can not only detect radiation, but also identify the type of radiation source in real time. So that ability to perform this real-time spectroscopic analysis is what truly sets SPRDs apart and makes them that much more powerful of a tool out on the field. So let's break this down together. So traditional radiation detection devices are primarily focused on alerting the user to the presence of radiation. They provide basic information such as radiation intensity, but they don't offer insights into the specific nature of the radiation source. This can be a significant limitation in situations where understanding the type of radiation is crucial for making informed decisions. So, for example, distinguishing between naturally occurring radiation and a potential security threat can be critical in scenarios involving public safety or environmental monitoring. So, in contrast, SPRDs are designed to provide a much richer set of data. They incorporate advanced spectroscopic capabilities, algorithms, which allow them to analyze the energy spectrum of the detected radiation. And this analysis enables the SPRD to identify that specific isotope on the spot. So, providing immediate and actionable information to the user. So, whether you're dealing with medical isotopes or industrial sources or even potentially hazardous materials, the ability to quickly and accurately identify the source of radiation can make all the difference in how you or I respond. But that's not all. So SPRDs are also designed with portability in mind. They are compact, lightweight, cost effective, easy to carry, making them ideal for use in a wide range of environments. So whether you're on the move or you're conducting inspections or stationed at a fixed location, SPRDs provide the flexibility and ease of use that professionals in the field really need and demand. So this portability doesn't come at the expense of performance. So SPRDs are equipped with powerful detection analysis capabilities that should ensure that the information that you need uh, when you need it is there. So we're going to give you a visual, show you how some look, how some differ. But as you can see, it's designed to be both user friendly and highly functional. So the compact design allows for the ability to easily transport it, while the intuitive interface GUI ensures that even users with minimal training can operate the device effectively. So this balance of portability and advanced functionality is what makes SPRD such an essential tool in the modern landscape of radiation detection. So as we move forward, keep in mind how these advanced features, real-time spectroscopic analysis, isotope identification, and portability provide significant advantages over your traditional radiation detection devices. So SPRDs are not just incremental improvements; they do represent a fundamental shift in how we approach radiation detection and safety by allowing users the ability to make more informed decisions quickly, enhancing both safety and efficiency in the entire hazmat radiation process. So now that we have a fundamental understanding of what an SPRD is and how it represents, like I said, a significant advancement in radiation detection technology, let's take a moment to engage with you, our audience. Your experiences and insights are incredibly valuable, and they can also help guide our discussion as we move forward. So we've prepared a quick poll to get a sense of your understanding with SPRDs. So the question is simple: have you ever used an SPRD? Your options are yes, no, or considering it. If you selected yes, that's fantastic. You're already familiar with the benefits that SPRDs offer. And I hope this webinar will deepen your understanding and highlight new ways these devices can support your work. If you've selected no, don't worry. By the end of this webinar, you'll have a clear understanding of why SPRDs are becoming a preferred tool in radiation detection and why they might be worth considering in your operations. And lastly, for those of you who are considering it, this webinar is tailored just for you. We'll be diving deep into the specifics of how SPRDs compared to other radiation detection tools and discussing real world applications that might resonate with your current needs. So, engaging with these poll questions not only gives us a sense of your experiences, but also allows us to tailor the conversation to better suit you and your interests. Okay, so now let's move on to a detailed comparison between SPRDs and regular radiation pagers, a topic that will likely address some of the considerations that you have in mind. So, as we continue, it's important to understand how SPRDs stack up against more traditional radiation detection tools, specifically regular radiation pagers. So, many of you may have already been familiar with these devices as they've been a staple in radiation detection for quite some time. But let's start by looking at what regular radiation pagers do. So these devices are designed to perform basic radiation detection tasks. They alert users to the presence of radiation by measuring radiation levels and then giving a simple indication visually or through an audible alarm when radiation detected is above a certain threshold. So they are relatively straightforward tools, which is both their strength and to some degree their limitation. The simplicity of some of these regular pagers makes them easy to use and accessible to a wide range of users. However, this simplicity does come at a cost, namely in terms of functionality. So regular pagers are excellent at telling you that radiation is present, but that's not where their capabilities end. But that's where their capabilities end. They don't provide any information about the type of radiation or its source. In situations where knowing what kind of radiation you're dealing with uh, is really crucial. This lack of specificity can be a significant drawback. Another limitation of a regular pager is their sensitivity. While they are effective in many scenarios, they may not always detect lower levels of radiation or differentiate between different types of radiation sources. So, this can be a critical limitation in environments where precision and accuracy are essential. This is where SPRDs truly shine. So, SPRDs take radiation detection to the next level by incorporating advanced features that address these limitations. So first and foremost, SPRDs offer isotope identification. So this means that when radiation is detected, the SPRD doesn't just alert you, it begins to analyze radiation to determine its type. So is it a medical isotope, an industrial source, something more concerning? The SPRD can provide this information into some degree real time, empowering you with the knowledge to make informed decisions quickly. Additionally, SPRDs are designed with higher sensitivity and specificity. They are capable of detecting lower levels of radiation and distinguishing between different types of radiations with a bit better, or depending on the type and make, but with better accuracy. So this makes them invaluable in situations where the nature of the radiation is just as important as its presence. So while regular radiation pagers are reliable tools, SPRDs offer a far more sophisticated and comprehensive solution. They will provide not only detection, but with this identification and greater sensitivity and specificity, this makes them the essential tool for professionals who need more than just a simple alarm. They need detailed, actionable information. So, as we continue, we'll explore more about practical applications of SPRDs and why they're becoming essential in modern radiation detection strategies. But first, let's discuss how SPRDs are being used in various industries and the impact that they're having in real world scenarios. So let's go to the next slide. All right. So now, having explored the capabilities of SPRDs and how they compare with regular radiation pagers, let's now turn our attention to another key player in the field, something that we really know in radiation detection: handheld isotope identifiers. So these devices are known for their high precision and ability to provide detailed gamma analysis. So making them a very powerful tool in the hands of professionals who require comprehensive radiation data. So, handheld isotope identifiers are sophisticated instruments designed for in depth analysis of gamma radiation. They excel at detecting and identifying specific isotopes and then providing detailed information about the radiation source. So these devices are typically used in situations where precise identification is paramount, such as nuclear facilities, research laboratories, and specialized security operations. So the data that they provide can be highly granular, offering insights that are crucial for very high level, complex decision making processes. But however, this level of detail and precision comes with certain trade offs, particularly in the terms of cost, portability, and ease of use. So, handheld isotope identifiers are often larger, uh, heavier, and some a bit more complex to operate than your standard SPRDs. They do require more training to use effectively. There is, to some degree, margins of error that can occur. Their size can make them less convenient to carry around, especially in dynamic or field-based environments. So this is why uh, SPRDs offer a distinct advantage. SPRDs are designed with portability in mind. They're compact, they're light, they're user friendly. So these are ideal for use in the field or situations where it's quick on the go. Radiation detection is needed. But despite their smaller size, SPRDs still offer powerful features, including spectroscopic analysis. Even if it's not identified, it still give you a spectrum, isotope identification, albeit with the focus on providing actionable data quickly rather than exhaustive, a lot of data. So it's just quick isotope. But let's compare the two in a practical context. If you are in a situation that requires quick decision making, such as an emergency response situation or a security checkpoint, and an SPRD might be your go-to tool. It'll give you the isotope. It'll let you know. It'll give you the file. So that information you could send to a reachback. But its portability and ease of use allow for rapid deployment, and its real-time analysis capabilities provide the critical info needed to make immediate decisions. But on the other hand, if you are in a more controlled environment, lead shielding, a lab where radiation data is required. You really need that, like in a nuclear power plant or a gamma analysis uh, industry. A handheld isotope identifier might be the better choice. So its ability to provide detailed N42 files, spectra is invaluable. Being able to be in situations where every nuance of the radiation source needs to be understood, multiple isotopes, SPRDs and handheld isotope identifiers each have their strengths, ideal scenarios. But SPRDs excel in scenarios where portability, ease of use, and rapid, just quick analysis are key. As isotope identifiers, those are best suited for high level individuals that know about radiation, that do require, uh, when you do need more analysis in those spectra files. So, understanding the strengths and the limitations of each device will ultimately allow you to determine what's the right one for you. So ensuring that you are equipped to handle a radiation detection scenario effectively. Budget's also important. So we'll explore how these tools and specifically SPRDs are applied across different fields of work. But first, we're going to take another quick poll to better understand the diverse applications and industries to represent today our audience. Okay, so to ensure that our discussion today is as relevant and tailored as possible, we'd like to learn more about the backgrounds and fields of those joining us. So we have a diverse group of professionals here, and Understanding your specific applications can help us focus on the aspects of SPRD technology that are most pertinent to your needs. So we've set up a poll question, and the question is, what is your application or field of work? The options include emergency response, medical, industrial, and also other. So if you're in emergency response, you know how critical it is to have a reliable tool. So portable tools that can provide immediate information. SPRDs with their analysis and easy to use design are perfect for quickly identifying radiation sources in the field, allowing responders to take appropriate and swift action. For those in security, whether it's border checkpoints, transportation hubs, or during big Super Bowl sporting events, SPRDs offer a discreet and effective way to monitor for radiation threats. So their portability means they can be used in a wide range of environments and situations, and their isotope identification capabilities help ensure that any detected radiation is thoroughly understood. And also another one application, medical, particularly hospitals and clinics where they have medical radioactive materials. Using SPRDs can provide a quick way to monitor for potential contamination or if orphan sources, iodine 131, if it's lost. Their ability to identify specific isotopes can be crucial in ensuring that all the radiation sources are properly accounted for. So, for those working in industrial settings such as manufacturing, energy, production, SPRDs can help monitor radiation levels to ensure both safety and compliance. So, their ease of use allows for regular monitoring and extensive training. And lastly, other. There's a lot of people in this webinar. So if you don't fit within that, if you're just interested in SPRDs, they are versatile enough to be applied in a wide range of scenarios. So the combination of portability, ease of use, real time data, it's a great tool. So understanding your application field of work helps us highlight the most relevant features and benefits as we continue. So as we move forward, we'll go deeper into how SPRDs are being utilized in these sectors and providing real world examples that illustrate their effectiveness and versatility. So, okay, thank you for answering the questions. Let's go to the next slide. Now that we've explored how SPRDs compare to other radiation tools, specifically pagers and isotope identifiers, it's important to focus on the specific advantages that make SPRDs stand out. So, particularly in field operations. So, SPRDs are designed with the needs of first responders, security personnel, and other professionals in mind, offering several key benefits that enhance their effectiveness in various scenarios. First and foremost, portability and convenience are major advantages of SPRDs. These the devices are compact and lightweight, so they're easy to use, carry, and deploy out on the field. So whether you're on foot, in a vehicle, or stationed at a checkpoint, the ability to have a powerful radiation detection tool that doesn't weigh you down or requires bulky equipment is invaluable. So this portability ensures that SPRDs can be used in a wide range of environments, from crowded football games to remote locations, without hindering the mobility of the end user. In addition to their portability, SPRDs offer real-time isotope identification. So this feature is a game changer in radiation detection. So it allows end users to immediately detect and identify the type of radiation they're in front of. So traditional radiation detectors might only alert you to the presence of radiation, but an SPRD goes further by analyzing the radiation spectrum and then identifying specific isotopes right on the spot. So this capability is crucial in scenarios where understanding the exact nature of the radiation source is essential for making informed decisions, whether it's distinguishing between a harmless medical cancer isotope, uh, that medical therapy, and a potential security threat, or quickly assessing the situation during an emergency response. Another significant advantage of SPRDs is their enhanced, to some degree, accuracy and sensitivity compared to pagers. So these devices are designed to detect a bit lower levels of radiation with greater precision, reducing the likelihood of false positives or missed detections. So this increased sensitivity is particularly important in environments where even small amounts of radiation could pose a significant risk or indicate the presence of illicit materials. So the accuracy of SPRDs also means that users can trust this data they receive, the spectra, which is critical when time is of the essence and decisions need to be made very quickly. So given these features, SPRDs are ideal for, like I said, first responders and security, fast paced, often unpredictable environments that these professionals work in. Having a tool that is not only small, reliable, but also easy to use, make all the difference. So the combination of uh, the gamma analysis, the enhanced sensitivity, acquisition time, allows first responders to quickly assess situations, protect themselves, the public, and take appropriate actions. So, similarly, security personnel can use SPRDs to effectively monitor for radiation threats in high traffic areas, the border, Canada, Mexico, ensuring that potential risks are identified and mitigated before they escalate. So, the advantages of SPRDs in the field are clear, but their portability and convenience make them easy to carry and deploy. And while their isotope identification and their better sensitivity provide users with the critical information that they need to make these features invaluable. And that's why we have a lot of customers, particularly in dynamic and high stakes environments like emergency response and security operations, that really like the strengths of these SPRDs. But it's also important to acknowledge their limitations. So no tool is perfect, and understanding where SPRDs may fall short can help ensure that they are used effectively and appropriately in the field. So we're going to move on to discuss some of the potential limitations of SPRDs, because again, you very general radiation detectors, pagers, SPRDs, isotope identifiers, and even high purity germanium systems. To some degree, they're all radiation. They're all doing radiation detection, but they all do it in different ways, and they do have their pros and cons. So we're going to discuss now some of the limitations that we might see with SPRDs. While SPRDs offer significant advantages, it's it's crucial to recognize their potential limitations to ensure that they are used effectively in the field. So by understanding these limitations, users can make informed decisions about when and how to best deploy SPRDs. So, one of the primary potential limitations of SPRDs is their limited analysis depth compared to handheld isotope identifiers, HPG systems. So, while SPRDs are equipped with spectroscopic capabilities that allow for real time isotope identification, the level of detail they provide may not be as comprehensive as what you would get with more specialized handheld isotope identifiers. So these handheld devices can offer more detailed analysis. Some even have the ability to quantify specific isotopes and provide extensive data that's very important for complex decision making scenarios. So this means that while SPRDs excel in quick, on the spot analysis, they may not be the best tools for situation requiring detailed, in depth gamma analysis. So, another uh, important consideration is the size of the detectors used in SPRDs. Um, some of them are designed, like I said, they're designed for portability and convenience, which means that the detectors themselves are going to be relatively small. So, these smaller detectors are commonly made from materials like cesium iodide can be less effective in certain situations compared to larger detectors made from materials like sodium iodide, lanthanum bromide, cerium bromide. So, for instance, cesium iodide detectors, while they're good for basic detection, may not provide the same level of resolution or sensitivity as sodium iodide or lanthanum bromide detectors are 2 by 2 or 3 by 3 inches in size. So this difference in detector size and material can impact the accuracy and the quality of the radiation data collected, uh, particularly in scenarios where high resolution spectroscopy analysis is required. So you really want to be able to differentiate between 3 to 4 isotopes. So that's something that SPRDs might have a bit of problem with. Lastly, additionally, battery life and operational considerations are important factors that you need to be aware of. SPRDs are designed to be portable, but this portability can sometimes come at the cost of the battery life. So depending on the specific model and how uh, intensely the device is being used, the battery life of an SPRD might be limited. So this can be a concern in situations where extended operation is necessary. So the access to charging facilities may be limited. So you might need swappable batteries or disposable batteries. But to address this, users should ensure their devices are fully charged before deployment and consider carrying, like I said, spare batteries and portable charging solutions as part of their field equipment. And there are situations where very high level gamma analysis is needed. And this is where other tools might be more appropriate. Like in settings in a laboratory, at one of the large laboratories here in the Bay Area, or during in depth investigations, the detailed data provided by handheld isotope identifiers or other specified instruments may be necessary to fully understand the radiation source or sources and their implications. So in such cases, relying solely on an SPRD could result in incomplete data and would necessitate additional analysis with more sophisticated equipment. So while SPRDs are powerful, they're great tools. Like I said, they do have their limitations. It's the smaller size. The resolution limitations could be around 8% uh, when you're measuring cesium 137 uh, compared to larger 2 by 2 sodium iodide, lanthanum bromide detectors. And then, like I said, coupled with some of the life challenges and the need for uh, the life battery challenges, the need for more detailed analysis, that's very important. So, by recognizing these issues to use SPRDs effectively, you just have to have the right context. You have to know when to use them. So, these tools to achieve the most accurate and comprehensive results, you need to know what your situation is. So, as we proceed, we'll discuss practical tips for maximizing the effectiveness of SPRDs in the field and best practices for integrating them into a more broader focused in detection strategies. Okay, so we've explored both the strengths and limitations of SPRDs. Let's focus on why SPRDs are often the optimal choice in many scenarios. So these devices are designed to meet specific needs of professionals who require a balance between portability, performance, budget, making them highly effective in a wide range of applications. But one of the key areas where SPRDs excel is in emergency response. So in emergency situations, time is of the essence, and the responders need tools that are both reliable and easy to use. So SPRDs offer the perfect combination of portability, isotope identification, allowing first responders to quickly assess radiation levels, and then do isotope identification right on the spot. So whether you're dealing with potential radiological incident, a natural disaster involving a damaged nuclear facility, or any situation where radiation might be present, SPRDs provide the immediate data needed to make informed decisions and take swift action. Um, Another critical application for SPRDs is border security. So at borders uh, and checkpoint security, law enforcement personnel need to be able to quickly screen vehicles, cargo, and individuals for radiation without causing a significant delay. The small size of the SPRDs make them ideal for those types of situations where security officers can carry SPRDs on their person, and then using them fast, non-intrusive scans that not only detect radiation but will also identify its specific source. So this capability is extremely important in preventing the smuggling of like radioactive materials, or the ability to differentiate between harmless sources. Potential threats can make all the difference. So law enforcement's uh, on the field out there, uh, it's invaluable. Police officers and other law enforcement personnel are often the first on the scene in situations where radiation might be a concern, like in the aftermath of an industrial accident or a terrorist attack, or when dealing with suspicious packages. So SPRDs will provide these officers with a portable, easy to use tool that delivers crucial information quickly. So the on the spot gamma isotope identification feature is useful in these scenarios, allowing law enforcement to quickly determine whether a situation involves a radioactive source or like just a benign material, banana or potassium naturally occurring. But what makes SPRDs truly stand out is their ability to balance portability with performance. So they may not offer the highest resolution or the most detailed analysis, but they excel in providing fast, actionable data in the field. The compact size of SPRDs combined with spectroscopic capabilities, it makes them their choice for professionals who need a reliable radiation tool that can be easily carried and deployed. So let's consider a scenario where imagine a security checkpoint at a major international airport where speed is vital. The personnel equipped with SPRDs can quickly scan large volumes of passengers and luggage, identifying any radiation threats without slowing down the flow of traffic. So, in this scenario, local SFO or Oakland, if they get a hit, there's radiation. With that SPRD, they'll be able to identify or get a gamma analysis, get a gamma file. It might be wrong, it might not even identify it, but having that gamma file, then they could send that N42 file to a reachback place and then determine what it is. Determine if it is medical or if it is something that shouldn't be there, like a special nuclear material. But that information very quickly will will make the lives easier of everyone involved in how to assess the problem. If it's just iodine 131, a medical isotope, and the passenger that's flying by is acknowledging that they told the officer that that's what they're dealing with, then it confirms it. They shouldn't be traveling if they have iodine 131, but some people will still do it. But that's completely different situation to someone that has like special nuclear material or something like that. So again, when speed, efficiency, and quickness is needed, when the individual doesn't have to have a, a major understanding of gamma analysis, all they need to do is really collect it and send it back to someone that knows it. SPRDs is the way to go. And again, costs, they're going to be significantly cheaper than a portable isotope identifier with lanthanum bromide, significantly cheaper than a portable HBGE system. So again, you want to make sure that you're you want to make sure that when you're buying or trying to decide between a pager, SPRD, a red, or a high purity germanium system, you have all this in mind when you're talking to a professional. So this is when you should truly be going for an SPRD. While SPRDs are they're highly versatile and effective, and like I said, many scenarios, there are certain situations where they may not be the best choice. So you have to understand these limitations. It's crucial for ensuring that your expectations are met and the right tool is used for the right job. So, particularly in environments where detailed gamma analysis or complex radiation sources are involved, uh, you need a that's where you need a portable isotope identifier. So, one such scenario involves cases requiring detailed gamma isotope analysis. So, while SPRDs are excellent for quick, on the spot identification of sources, they're smaller detectors, which are often made from, like I said, cesium iodide, will most likely not provide the same level of resolution as larger, more complex detectors using more specialized devices. So, for instance, larger sodium iodide, lanthanum bromide, and cerium bromide detectors, which are typically 2 by 2 or 3 by 3 inches in size, offer higher resolution and greater sensitivity. So these larger detectors are capable of providing more detailed spectroscopy data, which is essential when when you need very precise isotope identification and to some degree quantification when that's required. So in environments where complex radiation sources, like I said, such like nuclear power plants, research laboratories, or investigations, the ability to conduct comprehensive analysis is often a must. In these settings, SPRDs are not will not be able to provide the level of detailed needed to fully understand the radiation source or sources and its implications. For example, when dealing with mixed radiation fields, or when there is a need to differentiate between multiple isotopes in close proximity, handheld isotope identifiers or other more advanced equipment is preferred. So these devices are specifically designed to handle complex scenarios, offering the detailed gamma analysis that SPRDs might not be able to provide. Another situation might be uh, best choice when you're doing long-term monitoring data. SPRDs are designed for portability and ease of use. So which means the battery life might not last, and the data storage capabilities are optimized for short term on the go rather than using them for extended periods of times. So, in cases where continuous monitoring is needed, where large amounts of data need to be collected and analyzed over time, other devices, even backpack isotope identifiers, other devices with longer battery life, greater storage capability, and more robust data management uh, will be more appropriate. So, but I know SPRDs are powerful. They're versatile tools, but there are specific situations where they might not be the optimal choice. Like I said, cases that require N482 files, complex analysis, when you're dealing with multiple radiation sources and situations where long-term monitoring is is a must. Other devices like the handheld isotope identifiers, the backpack isotope identifiers, more advanced equipment will be needed. So again, by understanding these limitations, professionals can ensure that they're using the most appropriate tool. Just like when you're choosing between a pager, a SPRD, a handheld, a backpack, a big mobile system, area monitor, maximizing both safety and effectiveness. You need to know what your application is, what your intent usage will be, and then you could easily determine kind of whether or not the SPRD will work for you. So, all right, so we're going to open it up to the forum. We're going to open it up to the group. Let's take some questions. Okay, let me see. Let me adjust my screen here.